their ratios are always consistent. So in a 45, 45, 90, if the side across from the 45 is x, then the side across from the other 45 is also x, right? And the hypotenuse, which you probably don't remember, is whatever x is times root 2. So 45, 45, 90 right triangles have opposite side lengths of x, x, and x root 2. What that allows to happen, and 45 degrees, you'll notice on this chart down here, is a critical angle, is it allows the sine, cosine, and tangent of 45 degree angles, as well as anything that's going to have a reference of 45 degrees, to make sense why their sine, cosine, and tangent values are going to be what I'm about to tell you. So do you remember quickly SOHCAHTOA? Sine equals opposite over hypotenuse, right? Cosine equals adjacent over hypotenuse. That's the A and the H. And tangent equals opposite over adjacent. Follow? So because these ratios in a 45, 45, 90 right triangle are pretty straightforward, the sine of a 45 degree angle is always going to be its opposite, x, over x root 2. So for example, I'll do the sine of a 45 degree angle is going to be the opposite over the hypotenuse. That's an x over an x root 2. And the x's cancel, right? So that's 1 over root 2. And then if we rationalize, that's root 2 over 2. The sine of a 45 degree angle is root 2 over 2. And then we would be able to do the cosine of a 45 degree angle. And we would be able to do, let's just for the fun of it, do the tangent of a 45 degree angle. I don't know why I wrote the whole word tangent out. I should have just written tangent. The tangent of a 45 degree angle is the opposite side. Vince, what's the opposite side labeled on this? Good. I just said Vince, but that's okay. Vince, what's the adjacent side? Right. Opposite over adjacent is x over x, which would be what? 1. The tangent of a 45 degree angle is 1. And we could do that for the cosine as well, and the cosine, by the way, is also going to be root 2 over 2. It would pan out to be the same thing. And then for 30 degree angles and 60 degree angles, we're going to use the 30, 60, 90 ratio. Georgia? From here to here, I rationalize. So you can't have a radical in the denominator. So I multiplied by radical 2 over radical 2. Like that's our creative way of multiplying by 1 to change the appearance, but not to change the value. So in a 30, 60, 90 right triangle, you probably don't remember this, but the smallest side, if you call that x, the hypotenuse is always double that, so 2x. And the other leg is always x times root 3. So underneath the 30, 60, 90, I'm going to write x, x root 3, and 2x. So the 90 degree angle has an opposite side of 2x. The 60 degree angle has an opposite side of x root 3. And the 30 degree angle has an opposite side of x. So what this will allow us to do, and I'm just going to label this the 60 degree angle, is it will allow us to wrap our head around why the values for 30 and 60 for sine, cosine, and tangent are what they are. For example, let's do the sine of 30. Sine is, if I go up to my 30 degree angle, sine is opposite, which is what, Owen? Nope. The side opposite 30. X over the hypotenuse is? No. Okay, let's do this. Opposite over hypotenuse. What is opposite the 30 degree angle? x. What is the hypotenuse? Nope. Look at the picture. What is the hypotenuse labeled? 2x. Follow that? Does that make sense? So that your x's cancel and you're left with 1/2. The sine of 30 degrees, no matter how big the triangle, will always be 1/2. Okay? We could do a 60-degree angle. Let's just, for the fun of it, do the tangent of a 60-degree angle. So if I go to my 60-degree angle, tangent is opposite over adjacent. So Angie, what's the opposite of 60? X radical 3. And what's the adjacent to that? X. And so your x's cancel, and this just ends up being root 3. The tangent of 60 is root 3. Okay? So this idea is where the table comes from. I'm going to give you the rest of this table, and I'm going to also show you an easy way to know kind of where this comes from. You need to memorize these values at the end of the day. We will have flashcard quizzes where I'll just throw up the sine of 30, and you have approximately 2 seconds to write down 1/2. Okay, so you have to memorize these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 values. Just like you've memorized 8 times 9 is 72. Right? Remember those flashcard quizzes? Yes? So do you ever, when someone throws 8 times 9 in front of you, do you really think about 8 groups of 9 and why that makes 72 anymore? No, because you've memorized it. So you just know it. So you need to just, I would make 15 flashcards and I would just know these. So here's the progression. And these are our only angles that you have to memorize. 0 through 90, and these are the critical angles because of the special right triangles. The sine of 0 is 0. Sine of 30 we already filled in as 1/2. Sine of 45 is root 2 over 2. Sine of 60 is root 3 over 2. And the sine of 90 is 1. The cosine is really, you'll notice, it's going to end up being this column backwards. So the cosine of 0 is 1. The cosine of 30 is root 3 over 2. Cosine of 45 we already did. Cosine of 60 is 1/2. And the cosine of 90 is 0. And then I'll tell you one thing. Tangent is equivalent to sine over cosine. That's just something you should know that's going to help us in a couple different circumstances. The tangent is the sine divided by the cosine. So, you need to memorize these, but at the end of the day, you can also, on the little quizzes, this won't be fast enough, but you can also look and know that the tangent of 0 degrees is this divided by this. 0 divided by 1 is 0. 1/2 divided by root 3 over 2 will initially be 1 over root 3, but when you rationalize it, it becomes root 3 over 3. It should make sense a little bit from a different perspective now why the tangent of 45 is 1. Because anything divided by itself is 1. Root 3 over 2 divided by 1 over 2 is just root 3. And what's 1 divided by 0? Undefined. If on your calculator, and by the way, these are in degrees, so your mode, you don't have to do this. But if I were to find the tangent, and I'm in degrees, of 90 degrees, it's going to give me an error because it's undefined. Okay? So, those are the special degree versions of the angles. The equivalent in radians are 0, pi over 6, pi over 4, pi over 3, and pi over 2. Pi over 2 is the same thing as 90 degrees. Pi over 3 is the same as 60. So on your flashcards, you're going to have the sine, cosine, and tangent of all of those 5 degree angles, and the sine, cosine, and tangent of all of those 5 radian angles. which all have the same values. It's just a different way of putting it in front of you. Because half of this chapter will be in degrees and the other half will be in radians. Actually, it's probably more like 75% is in radians and only 25% is in degrees. Okay? So, make 30 flashcards. 15 for the degree measurements and 15 for the radian measurements. Capiche? And get memorizing. Just like you would for your times tables, right? Once you know the flashcard and you know it, there's no sense of having the 1 times 8s in the pile if you know it. Just focus on the ones that you don't know until you memorize it. Okie doke? So, at the end of the day, where this all comes from, you probably won't ever be tested on, but you need to know the values, and I just wanted to give you some background as to where those came from. They come from SOHCAHTOA, and they come from your special right triangle ratios. But at the end of the day, memorize them. Okie doke? All right. If a point 34 lies on the terminal ray of an angle in standard position, find the value of sine, cosine, and tangent. I really feel strongly that everything in the trig chapter comes back to SOHCAHTOA, like in almost every single problem. This is all based on SOHCAHTOA. This right here, and when I show you how to do it, you'll see what I mean. There's a point 34. I'm going to sketch that, and I'm always going to tell you in trig, sketch it. So 3,4 is approximately there. It doesn't have to be exact. And a terminal ray of some angle gets drawn to there. So just draw your terminal ray to that point. Right? It's almost like we have our initial ray. Oh no, where's my little gadget? Aw, it worked so well for so long. Maybe a bobby pin would do the trick. There's my initial ray. My terminal ray, oh God, even better. My terminal ray ends at 3,4. Follow? Okay, so my angle is here. Your angle is always the angle made with the x-axis, right? It's like your reference angle. And I'm always going to tell you to drop a triangle to the x-axis. So drop this altitude down and create a right triangle. The right triangle has to be created with the x-axis because your angle is created with the x-axis. So if this point is 3,4, how long is this? 3. You go over 3 units and then you go up 4 units. The beauty of that is we now have 2 sides of a right triangle, correct? And so how do you find the third side of a right triangle? Pythagorean theorem. So SOHCAHTOA and Pythagorean theorem are going to be clutch in this chapter. So 3 squared plus 4 squared equals your hypotenuse squared. That's 9 plus 16, which is 25. And so what is h? 5. H is always positive. We'll talk about sometimes legs being negative. So h is 5. So I'm going to take this and label now there. And they're asking for what is the value of the sine of theta. Sine is what over what, Jack? And so opposite. So what is the opposite of theta? 4. And what is the hypotenuse? Nope. I have a number there now. 5. 4 over 5 is the sine. Cosine is what over what, Natalie? Okay, so what's the adjacent and what's the hypotenuse? So 3 over 5. And the tangent is what over what, Jason? Opposite over adjacent, so 4 over 3. Correct. Good? Any questions there? Okay. There's a little acronym. Now, do you follow that, like, this is positive because we went to the right, and this is positive because we went up? Do you follow that? And the hypotenuse is always positive. If my triangle happened to be at the point negative 3, 4, you don't need to write this necessarily, but I'm just trying to make sense of this next point for you. If this was negative 3, 4, you would label that negative 3. And this is still a positive 4, and your hypotenuse is always positive, so that would still be a 5. Your theta would be here, right? So if you were in the second quadrant, your sine, which is opposite over hypotenuse, would still be 4/5. Agree? Your cosine, however, would be adjacent over hypotenuse. And that would be a negative number over a positive number. So cosine is negative in that quadrant. And your tangent would be opposite over adjacent. So it's still 4/3, but it would be negative 4/3 because a positive over a negative is a negative. So tangent and cosine, because they involve this negative side, they would both be negative, whereas sine would still be positive. Do you follow? Okay? If you get down and you were to do a triangle in the third quadrant, and this was negative 3 still, because you're going left 3, this, though, because you're going down, would be negative 4. Do you follow that? And the hypotenuse, always positive, would be 5. So your sine would be opposite over hypotenuse. Still 4/5, but negative this time. Right? Because it's a negative 4 over 5. Your cosine would be adjacent over hypotenuse. Negative over positive would be still 3/5, but it would be a negative 3/5. And your tangent would be opposite over adjacent, which is a negative over a negative, which is a positive. So in each quadrant, only, except for the first one, because this stands for all functions are positive in the first quadrant, because these are all positive lengths. But based on the negative lengths showing up in other quadrants, in the second quadrant, only sine is positive. The other two are negative. In the third quadrant, only tangent is positive. The other two will be negative there. And in the fourth quadrant, cosine will be positive, and the other two will be negative. So to remember this, some people say all students take calculus. Mr. Hill says all students tip cows, because he grew up on a farm. I've heard other inappropriate ones as well. But all students take calculus is what I learned. So that little acronym there will tell you what is positive in each quadrant. Okie doke? So, figuring out what quadrant things are in. If sine is negative, which quadrants can we cross out that it can't be in if sine is less than 0? So sine is negative. 1 and 2 are gone. So it has to be 3 or 4. And if cosine is positive, which one is it? Fourth quadrant. Very good. Can't really show any work for that. So you have to really pay attention to my explanation and go back and listen if you forget tonight. In the second example, sine is positive, so it has to be one of which two quadrants? 1 or 2, so these are out. And tangent is negative. So which one of these is tangent negative in? The second one. You follow that? Okay. So you may just be asked what quadrants things are in. Last one here. If tangent is negative 2/3, so tangent is negative. So it's not in the first quadrant and it's not in the third. Tangent's negative. Cosine is positive, so which is it, second or fourth? Fourth, okay? So I'm going to draw a terminal ray in the fourth quadrant. I'm going to drop my right triangle. I'm going to label my theta with the x-axis. And tangent is what over what again in terms of SOHCAHTOA? Opposite over adjacent. So the opposite side is negative 2, and the adjacent side is 3. What's the hypotenuse? We have to do the Pythagorean theorem. I'm just going to tell you for the sake of time, it's going to be root 13. We had to calculate that. 3 squared plus negative 2 squared equals what squared? And now they're just going to say, what's the sine? So you tell me. Sine is what over what? Opposite over hypotenuse. So that would be negative 2 over root 13. We'll have to rationalize that. And cosine is adjacent over hypotenuse, right? So the adjacent side is 3 over the hypotenuse is root 13. Okay? The section on the bottom is exactly the same. They're just telling you, they're giving you some information so you know which quadrant to draw it in. For example, in this first one, and you don't have to write this down, just watch. It's in quadrant 3. So draw your terminal ray in quadrant 3. Drop your altitude always to the x-axis. Label your angle. It's like your reference angle. So sine, which is opposite over hypotenuse, your opposite is negative 12. Don't move. Your hypotenuse is 13. You'll find your missing side, and then you'll find the cosine of your angle and the tangent of your angle because they already gave you the sine. So it's all about drawing triangles, completing the triangles, and using SOHCAHTOA. Capiche? Here comes your homework. It's a worksheet, and on the bottom of your notes, I tell you which numbers to actually do, and the answers are on the back. It's like I'm just silly and good reading, huh? You gotta remember that the bobby pin is even better than my stapler. Mm-hmm.